In lesson 2.8, we are graphing inequalities. So you're going to do this the same way you would graph a line, just you're going to have to shade one of the sides afterwards. So pretend this says y equals mx plus b. So the m would be 1 and the b would be -5. So we start at our y-intercept, which is -5. And from there we go up 1 and to the right 1. All right, because the problem says greater than or equal to, we're going to put a solid line. And the only difference now, you're going to shade one of the sides. So greater than means you're going to shade above the line. If you have trouble figuring out which side is above and which side is below, you can always plug in a coordinate. So usually the easiest coordinate to plug in is 0, 0. So if you plug in 0 for y and 0 for x, you get a statement that is true. So because this is true, 0, 0 should be in the shaded region, which it is. Okay, number 2 is not in slope-intercept form, so we need to move this 4x to the other side by subtracting it. So we get y is less than or equal to -4x minus 1. Our m would be -4. Our b would be -1. So I go to -1 on the y-axis, and I go down 4 and right 1. Right, to go the other way, I'm going to do the opposite. So I go up 4 and left 1. Right, this one says less than or equal to. Because the or equal to is there, we make a solid line. And this symbol is less than, so we graph below the line. So imagine if that was a slide. This would be you being under the slide, and the other side would be on top of the slide. So less than means under the line. Okay, number 3 is already in slope-intercept form. Our slope is 1/2. 1/2 is the number being multiplied to x. Our y-intercept is -4. Always start with the y-intercept. Okay, from there you go up 1 and 2 to the right. And to go the other way, we go down 1 and 2 to the left. Right, this one says less than. It is not less than or equal to, so we make a dashed line. And less than means shade underneath. Number 4 has some decimals. So first thing we have to do is get y by itself. This needs to move to the other side. Negative 0.25y is less than negative 0.5x plus 1.5. Right, now we have to divide everything by negative 0.25. This is going to become y. When you divide by a negative, you flip the inequality around. Negative 0.5 divided by negative 0.25 is 2. So 2x. And then 1.5 divided by negative 0.25. Well, $1.50 is 6 quarters. And a positive divided by negative is a negative. So $1.50 is 6 quarters. So we have a 6. Our m is 2. Our b is negative 6. So we go to negative 6 on the y-axis. And we go up 2, right 1, up 2, right 1. Right. I want a dashed line because it's not or equal to. And you want to look at the symbol not from the original problem, but actually from when you put it in slope-intercept form. So even though the original says less than, when we isolated y, it was greater than, so we want to be above the line. All right, and now we have a word problem. A school system is buying new computers. They will buy desktop computers using or costing $1,000 per unit, and notebook computers costing $1,200 per unit. The total cost of the computers cannot exceed $80,000. All right, so I think I'm going to use D for desktop computers and N for notebook computers. So we need to write an inequality that describes this situation. So it looks like they're going to spend 1,000 times D number of computers, and then they're going to spend 1,200 times N number of computers, and cannot exceeds means less than or equal to. Cannot exceed 80,000. All right, the easier way to graph these, so usually for word problems, the easier way to graph it is to find the intercepts. So in the past, we have found x and y intercepts. For this one, we have d and n, so we're going to find the d and the n intercept. So to find the d intercept, you're going to plug in 0 for the other letter. So you're going to plug in 0 for n. So if I want the d intercept, I just pretend that the n is not there. I'm going to change it to an equal sign. We're going to shade later, so it doesn't matter. We're just trying to find a point. So d is going to equal 80. 80,000 divided by 1,000 is 80. All right, and now we need to find the n-intercept. So again, to find the n-intercept, you plug in 0 for the other letter. So the 1,000d is just going to be nothing, because it's going to be 1,000 times 0. So to find the other intercept, I have to take 80,000 and divide by 12. My calculator says that that equals 66 and 2/3, or 66.67. All right, so on the d-axis, I want to graph the point 80, 0. So basically, that's saying if they bought all desktop computers, they would only be able to afford 80. If they bought all notebook computers, they would only be able to afford 66 and 2/3, which is up here. Right. So the intercept method, you graph the two intercepts, and then you connect it with a line. All right, and where do I want to shade? So if you think about it logically, this is money we're spending. And if it's money you're spending, usually you want to stay below a certain value, so you shade underneath. Then another way to look at it, if you plug in 0, 0, does that meet your requirements? Yeah, if you plugged in 0, 0, you would definitely spend less than 80,000 because you're not buying anything. All right, so we wrote an inequality to describe the situation. That's the answer here. Then we graph the inequality, and now we have to answer a question below. The school wants to buy 50 desktops and 25 notebooks. Will they have enough? So there's two ways to do this. One, you can look for the point 50, 25. All right. Because my line is not perfectly straight, it's kind of hard to tell if the point 50, 25 is in the shaded area or not. So 50, 25 is around here, but because my line isn't perfectly straight, I don't really trust it. So I think the better way to do this problem would be to plug in 50 and 25 right there. So 1,000, and we want 50 of those. And then we have the $1,200 computers. We want 25 of those. If we do this, I'm going to put a question mark here. Will we be under the $80,000 budget? Need one more zero. So 1,000 times 50 is 50,000. 25 times 1,200 is 30,000. So it looks like they're going to spend exactly the amount. They're going to spend the exact amount that they are allowed to. 80,000 is less than or equal to 80,000. So will they have enough? The answer is yes. So yes, they will have enough. On the back, we are graphing absolute value inequalities. So you want to make sure you put it in the form that I taught you. That way you could find the vertex and the slope. So number 6 is already in that form. So our vertex is 0, 1. And our slope is 1, so we go up 1 to the right. And with absolute value, you do the same thing on the other side. So we're going to go up 1 on the left as well. Okay, the or equal to is there, so we connect it with solid lines. And then we figure out where to shade. Greater than means shade above, so we shade inside of here. Okay, so number 7 is not in the form that we want, so we have to put it in that form. All right, so we haven't done anything like this before. So notice for my template, I want x to be in the front of the inside of the absolute value. So there's a -2 there. I don't want that -2 to be there. So what I do is I factor out a -2. So what I'm going to do, I'm going to take this number and divide it by -2, and I'm going to take the +1 and divide it by -2. So -2x divided by -2 is just x. 1 divided by -2 is -1/2. Okay, so I know the absolute value of -2, so I can take the absolute value of -2 and remove that out. The absolute value of -2 is +2. The x minus 1/2 then stays on the inside. Right, so why did the -2 become +2? We took the absolute value of it. The absolute value of -2 is +2. So now we can see our vertex is 1/2, 0. So that would be right here, around there. And our slope is 2, so I go up 2, right 1. So all these coordinates are going to be in the middle of two x integers. So we graph this one with a solid line. And less than means shade below. We shade outside. Okay, for number 8, we need to get y by itself, so I need to divide by 2. Remember that dividing by 2 is the same as multiplying by 1/2. So I multiplied both sides by 1/2, and now I know the vertex is at -1, 0. We always do the opposite of what's inside, so -1, 0. And then we go up 1, right 2. Okay, this one we're going to make a dashed line because the or equal to is not there. And now we're going to shade below. Okay, next one. So remember the format we want to get it in. We want x to go first. So negative x plus 2 is the same thing as 2 minus x. We don't want that negative to be in front of the x. So we take out a negative 1. So if I divide negative x by negative 1, I get positive x. If I divide positive 2 by negative 1, I get negative 2. All right, now this negative 1, I can take the absolute value of that. The absolute value of negative 1 is positive 1. So imagine a positive 1 gets removed outside. And we don't really need the 1 in the front, so it's absolute value of x minus 2 minus 1. So we go to the vertex, which is 2 comma negative 1. And our slope is 1, so we go up 1, right 1, and we go up 1, left 1. This one is a dashed line. And greater than means shade above. Okay, that's it for lesson 2.8.